Hey, hello everyone, welcome back. So in our last tutorial, we had created a camera preview and a camera source, which enables the camera onto our screen, and that camera will detect our face, and the photo or the bitmap will be sent to a machine learning model to train that image and detect the face and expression from it, right? So, but we had not connected it to our main screen yet, so it is not visible onto our screen. So today we are going to write some code to train that model and to enable the camera onto our screen, as well as it should detect the expressions and our smiling face, right? So let's start with our models. So as you can see, I had already created some files here, and I'll explain you step by step what these files do. So just go to a project and create a models directory here, and inside that create a simple Kotlin file. And this Kotlin file is nothing but our model class. If you remember, our application contains the green box which detects the face onto our screen. So this that green box should have some contents like left margin, right margin, top margin, and bottom margin. So this rect model will have those contents constraints. So I had created this model class which have four map parameters: left, right, top, and bottom. So once you do done this, then create one more directly into our project, that is common, and inside that we will create the one more class which is bitmap utils, and it should be an object class. And inside this we are having two methods. The first one is a get bitmap and second one is a rotate bitmap. So the get bitmap, now as if you remember our last tutorial, we created this vision image processor. So what this just a minute. Yeah, we created these two things. The frame that metadata is a different part, but the vision image processor, what it does is it captures it whenever the camera is enabled onto the screen. The whatever objects it comes in front of it takes that image, and frame by frame it passes to our machine learning model. So that frame by frame, when we get the image in frames, that is the byte array, we need to convert it into bitmap, and then we need to check whether it's what is its dimension of that image, right? So for this reason we are creating these two methods here. The first one is a get bitmap. It will take the byte buffer, that is our image data, and will convert it into our bitmap. So if you see here, we had created a variable for image in buffer, and we got this data here, and we had created an array, and one by one we are adding frames into it. Now we are having try and catch blocks to handle the exception, and inside that this code will return us the bitmap of that frame. If you see here, we got here bitmap that is stored in bmp variable, and then we are passing that bitmap as well as the metadata of that frame to rotate bitmap method. Now this rotate bitmap method verifies that what is the orientation of our image, whatever image we are having, what is orientation of that, and we determine it by using Firebase Vision Image metadata, right? So once we get the orientation of that bitmap, we create the new bitmap with the new orientation, that it should be a straight image. It should not be a horizontal image. It should be straight and vertical image and clear. So once we get that image, we return it to this method, and then we return the original bitmap image by this method. If you see here, we are having a return statement. Now this bitmap utils will return us the image that is vertically straight. Now once we're done with this, then we should create one more file which is camera image graphics. Now this camera image graphics, uh, it is used to draw camera image to the background. For example, when our camera is live onto the screen, it continuously keeps on tracing the frame by frame and passes to them. Now this bitmap utils converts that frame into an image, and that image will come here, and it will draw that image onto our camera, right? So indirectly we are customly creating our own camera which is live, right? So by using canvas class, we are drawing that bitmap onto our camera screen so that we can see what is in front of that camera, right? So this is used to draw the bitmap which we got from this onto our screen. Now once you had done with this, you need to come back to this common directory and you need to create a new file which is vision processor base. Now this vision processor base is the file to keep which holds the your current image that you are having onto our camera, which is live. It holds that image, as well as it holds all the metadata of that image. Metadata in sense of what is its orientation, what is left, right, top, bottom constraints, as well as what is when it was at the byte buffer, that image, what was its byte buffer data. All those information is available in this class. So right click here in commons directory, create a new file with name as vision processor base, and create this class. And this vision processor base will extend the class vision image processor, which we created in our last video. If you control click here, you can view this class. Basically this is an interface, but we are extending implementing this interface using this class. Now in this class we are having some of the variables like latest image metadata, processing image, and processing image metadata. Now it means that these two variables, let me comment here so that you will understand what we are actually doing here. So these two variables are used to keep the data of latest images that are coming in front of our camera, latest images and its metadata. Now these two variables, I'm talking about these two variables as name says, and the below two variables will be responsible to keep the images and metadata which is under here. Yes, okay. Now we are having two types of images here. The first one is the latest, which are coming in front of camera, that you can call it as a queue, that is standing in the queue to be processed. But we are already having some previous images that are under process, so that under process data will be here and the new coming images will be here. Now because we had extended this interface, it has three methods, that is process and stop and the process. Now those all methods we are going to implement in this here because we are extending them here. Now first one is the on process. Now we get here three types of parameters. The first one is a byte buffer, that is the image in front of camera is in format of byte buffer. Then the metadata of frame data of that image, and the graphics overlay, that is the green box parameters. Now the latest image will be assigned to our byte buffer, and the latest image metadata will be assigned to this frame data. And then if we'll check if it is not if processing image, which means the image under processing which we are having is equal to null, at that time we'll say that process is equal to null, which means that under process has been completed. Now our memory is free to process the new image, so we will pass our graphics overlay to this method to process latest image, and we have already created this method here. Now this method will again check all the validations here, and it will again call process image. Now here actually we are processing our image to be to detect the face, right? So here we are having a variable of metadata, that is Firebase Vision image metadata, that is internal class of Firebase Vision library dot builder, and then we are setting the width, height and image format and all the things. Then we are converting that image into bitmap, and then we are detecting the image vision by using this method. Now here we are having this detect in method, that is internal library. We just need to pass that image into this library, and this library will perform all its operation to detect all the things, and then it will come to on success listener, and if it fails to detect the face, it will come here. And then if once it has been success, then again it will check whether the processing image is null or not. If it is null, then it will give it a latest image, then it will pass the latest image to be processed. Then after process, we are having the stop method. Stop method does nothing, and we are having success and failure method. Now once we are done with the vision processor base, then we should go to our next class, that is interfaces. We need to create some interfaces here. So right click here inside your project, create a new directory with name as interfaces, and create two interfaces inside that. Now the first interface, it has two methods, that is face located or face not located. So once the face has been located onto the screen, at that time it will come in this method, and it will have the all the data of that face, left, right, and top constraints. And if it is not located, it will be here. Now we are going to override these methods, extend this method inside our face detection processor. I'll come to it, but before that, let's see what resources it requires. So first of all, it will require this interface. It will require one more interface, that is frame return. Now once the face has been detected, we need to draw that green overlay onto that, and then we need to return the frame of that face. So for that we'll need this method here, which will contain image in form of bitmap, Firebase Vision face to detect which face has been detected, frame metadata, and graphics overlay. Now once we are done with our interfaces as well, we need to come to our vision directory. Right click here and create a new directory with name as visions, and then we are going to create a new class. Then we are going to create a new class whose name is face graphics. Now this face graphics class will be responsible to detect the face onto the screen, and render the face position, orientation, and landmarks within the associated graphics overlay view. Now let's come down and let's see. Now this face graphics extends okay, yeah, it implements the graphics overlay class, which is used to draw that green box onto the screen, right, as I told you before in our first video. Now it extends this class, and once the face has been detected, these methods that having this graphics overlay will be responsible to draw and that green box onto this screen. Now if you come little bit down here, we have declared some variables here, but below that we are having the draw method, which is from this graphics overlay. I had already showed you that here, this draw method. Now this draw method draws the face annotation for the position of supplied canvas. Now we are having the face here, right? This internal class will return us the face, and then depends on that face, we'll decide the x and y value of our green box to detect the face. And after that, using the canvas class, we are going to draw that box onto our camera, and once it has been done, it will check whether it's right or not as per our face detection status. As in rect model, we are having that all the constraints of our face we are passed here. Now once we do that, once we're done with that green box drawing, then we are having some objects here with the constraint at what should be a box width. I had given this 5.0. You can make it more thin by reducing this value, and text size what should be. Now after that, at the top I had declared some variables that are initialized at the bottom in initialization method. Now once you are done with the face graphics, let's come back to our different vision method, that is face detection process. Now here actually we are going to detect our face, and we are going to call this method to draw that green box onto our face. Now this face detection processor extends our vision processor base that we had created some time before, which is used to process the image and takes the latest image to the queue once the previous image has been processed. So as you can see, we have declared some variables here, which the face detect status, which contains the status of whether the face detected or not, and then face detector or class, overlay bitmap, and frame handler. Now we are having the stop method. If we call this method, it is going to stop detecting face onto our screen. And then we are having the method as detect in image. Once it passes the frame vision image here, and when it has been detected, it returns that image from this method. And after that, we are having the failure, which returns as a fail, which comes here when we are failed to detect our face. And then we are having two methods that has been extended from our detect status, that on face detected and on face not detected. This both the methods, it comes here when the face has been detected onto the screen, and if it is not detected, it comes here. Now we are having the initialization method where we had initialized our Firebase Vision Face Detection library here, which runs the machine learning model to detect the face and draw the overlay bitmap onto the screen. Now at the end we are having the success method, which clears the overlay, and every time at every frame it refreshes our camera and start detecting the face again and again onto the screen, right? Also it checks the camera facing, whether it is front camera or back camera, and all the metadata of our camera it passes to our other classes. Now once we had done with all this, let's now it's time to attach our camera and graphics overlay onto our main activity. Now let's come back to our main activity. Now this is my main activity. If I scroll a little bit up, if you see here, I had already extended some classes here. So the first one is a base activity class, which I had created in here base directory. So this is our base activity class. Now this activity, if you see my application, if you look my application, we are not having toolbar here, right? We are not having toolbar, not, and even we are not having status bar here. So to make to make our screen to a full screen, to hide the toolbar as well as the status bar, here I am having the base activity, which sets the flags of our window to be full screen. So we had extend to make our application full screen. I had extended this base activity. After that, we need to if we are using the camera of your mobile phone, we need to ask for the permissions to the user, right? So for that, I had created one more method, that is public method, which contains the permission stuff. So if you see here, I had also extended my permission result by callback. So that is the public method. Now after that, it will return if the request has been if user had allowed or not. So for that, I'm using extending here the callbacks. After that, I'm having the frame return, that is the frame, all details of the frame, and frame detect status. If the face located, it will return me the status. So all this I had extended here. I had created here some variables such as camera source variable, preview, camera preview variable, all the classes, all the variables of the all classes. And I had already shown you this layout I had created in my first video. If you had not watched that, please watch that. Now I had shown you how to create this layout. I had used the camera preview, I had used the graphics overlay, and we had created this layout. Now I had initialized all those my UI components. Now the first thing I'm doing here is I'm checking if I'm having a permission or not. So in public methods we are having all the permission checking methods. So first we'll check all permission granted or not. So the permissions, get required permission. What permission we need to check? That I had kept here in package manager. Go and check the permissions for camera, and it will check that, and if it is granted, it will return true, else it will return false. And then we are also checking the get runtime permissions. All needed permissions, we are having all the permissions into an array list of this, and it also returns the true if it has been granted, or else it returns the false. Now once all the permission has been granted, we are calling the method as create camera source. Now in this camera source method, we'll check if camera source equals to null, then please initialize that camera source. So we are initializing using camera source class, and we are passing it a graphics overlay. Now in try and catch block, to handle the exception, we are creating the variable of face detection processor, the class that we created sometime before, and then we are giving is the context of the current class, frame handler and frame detect status, and then we are starting our machine learning frame processor here by calling this method. Now once it if it catches the exception, it will show us the toast message that cannot be able to create the image processor. And then we are having on resume and on pause method. If we minimize our application, then camera should be stopped, so I'm calling the stop method. And once it again resume, it will again go to start camera source. Now in start camera source, we are checking if camera source is null or not. If it is null, initialize that, else start our camera again. Now let's come a little bit down, and if you see here, we had override the on frame located and all frame not located method. So once the frame has been located, it will come here, and if it is not located, it will come here. And then we are this is the overridden methods, which tells us that even that if the permissions has been allowed or not. So once the permission has been granted, it will again create the camera source onto the screen. Now everything is ready. We had attached our camera source onto the screen and everything is ready. Let's run the program and see if it. As you can see, our application is up and running, and if I take this camera in front of my face, it detects my face, as you can see, and the green box, it shows me the green box. And if I move camera to some other place, it disables that green box, and if I put it into my face, it again shows the green box. So it means our application is working fine, and the only one functionality has been remaining now. It is not detecting my face expressions, right, as you can see. So that thing we are going to do in our next video, and seems good. So let's meet in our next video. Thanks for watching.